So hello, I'm Frederick Dunn, and I want to welcome you to another interview with an expert. If you're looking for a fast and convenient way to profoundly reduce varroa mite loads in your honeybee hives, today's conversation should be interesting to you. My special guest today is the owner and designer of InstantVap, a battery-powered, completely portable oxalic acid sublimator. Please stay with us as Janos Fenyosy explains the importance of temperature parameters when sublimating oxalic acid. Here's Janos.
My name is Janos Fenyosy. I live in Hungary. I'm located in Etyek within Hungary. It's close to the capital city, Budapest. And I'm living from manufacturing InstantVap and developing it now. I used to work for companies, leading engineers, mainly in the last 6 or 4 years. But once I started up with this company, InstantVap, and saw how big potential is there, I fully dedicated my time to this.
Mm-hmm. Okay, well, thank you for joining me, and I'm glad that you agreed to do this interview. I reached out because I wanted to talk to you about how you got to where you are and what led you to develop your latest iteration of the InstantVap. So, we've got where you're at now, but let's backtrack a little bit and talk about, first of all, your relationship with beekeeping. That goes back to your childhood, am I right?
So my father used to keep bees. In fact, he still has a couple of hives now. And I grew up having bees around me. We always visited other beekeepers, and I loved everything about beekeeping. I've got a couple of brothers and sisters. Nobody was really interested in it, only me. So once I graduated and had my own garden, I right away bought some hives. In fact, I didn't have my house yet there, but I already, not even the fence, but I already had my bees. Mm-hmm. So I really miss them. And I started keeping them, I think, in 2016. And I started with the usual Amitrust type treatment, against varroa destructor. And it did work to a certain degree, but I was shocked when I recognized, when I got to know that my father lost all of his bees, like 35 hives in one winter due to varroa. And he always used the same treatment, and something changed. And I started to look at it, and I got to understand that they got used to it, and they are not as this treatment against varroa mite is not as effective as it used to be. And because he didn't track it, he just went with the habit. He didn't know what mite load he had, and eventually all of his bees died during the winter. So that's when I started to look into this topic, and I already heard some things about oxalic acid, but I just wanted to try it out. First, I just bought a very simple tool called Mite Gun. And what I liked about that is that I recognized what heat gun it was using, and I just had to buy one part of it, which was quite cheap, and I thought everything is fine. So you just had to load in the oxalic acid into that, like 30 grams, and then you warmed it up to about 600 degrees Celsius. And it was starting to bubble, and then you had to lower it to around 450. And then I just followed the instructions, trusted it, and treated my bees. And what happened was that within a couple of months, I saw that it is not working. They were just getting a lot of mite load. I could visibly see the mite. I could see the deformed wing syndrome, and I had to go back to Amitrust. So I bought another tool and started to treat with that. But I just didn't accept it that it is not working. So I digged more into this issue and had some beekeeper friends, and they said that they do vaporize and it is working for them. So I knew something is wrong with me. And it led me to kind of understand that when we apply a lot of oxalic acid into a cup and just warm that up and vaporize from that, then what happens first is that the crystal water contact of the oxalic acid boils up, and then it starts to create a fog, but that is not really oxalic acid, but more or less it is just water. And because it's like cold outside, you see it as an oxalic acid fog, but I was treating them mainly with water, so to say. And also I understood that overheating is not very good, so maybe I was treating them partially with water, and as I was getting to the end of my hives, I was treating them with formic acid. So it just didn't work, and I decided to, to look into it, which is the good tool to buy. And in Hungary, ProVap is well known, so I just bought one of his device and powered it up, and was happy that it has a temperature control. I can set up whatever I want. And I did that, but I was shocked when I saw that it was heating up instead of the set temperature 230, it went up above 260 degrees just as I started it up. And then it kind of changed between 225 and 246, 47 degrees, just without adding any oxalic acid. So I started to use that. It is a working device, definitely. Many people are using it. I use it also for a full year, but I just couldn't accept it that it is cooling down that much as well as overheating that much. I mean, in summertime, I had to wait till it cools down, and in winter time, when there was a bit of breeze, it was clogging and so on. So it's like it was. I just saw that everybody's just copied one type of vaporizer, probably Sublimox or something like that, and came up with his own version. But pretty much it was a copy of each other, and nothing too new about it. And having stuck it in my garden, it was not a big deal, but still I had to like 60 meters of extension cord in the morning before work in wet grass, and setting it up and putting it away. Just I'm a lazy guy and I didn't like that, and started to think about whether a battery-powered vaporizer can be made. And interestingly, everybody told me it's not possible. Whoever I talked to, they said it's just you need too much power. It's not possible. And I started to do some experiments at home in the early mornings and evenings when the kids were in bed, and I started to see that it is possible, definitely, and it's not outside of the reach. And the more I experimented, the more I saw that it is possible, and it is even better than the corded one if it is designed differently. If you can compare like corded with like cordless one, but how fast you can go and how is it to use. And I thought that maybe only up to 10 or 20 hives they will use it, but the more I looked at it, it was feasible to use it, I think, even in commercial environment. So that's when I kind of started to put in more and more of my time and money. And interestingly, with, I would say, less than $1,000, I did 90% of the development. So it was really with very, very simple tools. I remember I didn't have a data log or anything, so I just took a video of everything, and I stopped every second and written down the temperatures, and I created the curves of the temperature and how it is overheating and so on. So I just had to find the easiest way. I didn't want to spend too much money in the beginning when I didn't know whether it is feasible or not. And interestingly, just with a power meter and a couple of very, very simple tools, I did everything pretty much. Having the background of electrical engineer and manufacturing and so on, it was I have had some advanced in that.
And I'm glad you mentioned that, because I'm sure a lot of people are watching or listening and thinking, who does that and just puts all this together? But you've mentioned that you do have this background in engineering. You're an electrical engineer. You graduated from college for that. Is that right?
Yes.
Okay, so, and it's interesting too, because you did mention the unit's ability to retain the proper heat and not, of course, overheat, but also not cool down too fast, which also helps you draw less power from your portable battery pack, for example.
Yes.
Can you explain a little bit your thinking behind how you arrived at something that would I have two batteries here. Like, for example, this is the DeWalt 60-volt flex volt. It's 12 amp hours.
Yes.
And a lot of people have these little versions, 2 amp hours.
Yes.
But if I had this one, you know, which a lot of people do, I can treat my entire apiary with this battery.
You can treat around 100 hives with 2 grams with that.
Yeah. So for me, it's 29 hives, so I'm safe.
Yes, definitely. Don't need to look at the voltage meter.
Yeah.
It's a couple of things. First of all, everybody used a clamp heater. So clamp heater is heating up the side, but 50% of that energy right away goes to the air. And the other disadvantage of that is that you are heating the side, but when the oxalic acid drops in, it is cooling down the bottom. And by the time the temperature arrives to the bottom of the bowl, there's a time shift, and that causes the overheating. So these vaporizers have the pit control possibility, but they don't use that, because if they would use that, that would mean that, let's say, 20 degrees before it would reach, or maybe 30 degrees before it would, before the set temperature, it would start to switch on off if you would use the pit function. And it would become very slow if you don't want to overheat your bowl over the set temperature. So what they do, they just use an on-off function. It switches on at 228 if you set 230, and switches off at 230. So there's a 2 degrees of gap, and that's all what it does. And if it's summertime and hot outside, it really overheats like 30 degrees. And if it is winter time, it is struggling because there is no insulation on it.
Right.
People played around with putting on some insulation, but then this cup design of adding the oxalic acid there, it means that that insulation will get soaked with those, with the residue from the oxalic acid, and eventually looked likely to short out that heater. The other thing which I kind of didn't like is it's corded, and then the chance of electrical shock is like, it really, really troubled me. And I have everything, and I even bought and designed everything for the corded version, and I decided not to launch that, although it is like not even better than the battery one, because it can be very efficient, because you don't need to worry too much about loss of temperature, and you can add a little bit bigger wattage of heater, so that you can faster reach the temperature, and it is not dropping back that much. But having like a stainless steel body, which I think is like quite necessary for oxalic acid not to rust anything, and plastic is not too good for the temperature. It's just even if I would ground everything as per standard, and I would kind of safeguard my back, I would be very worried that most of the beekeepers do not use RCDs and any kind of protection, and they just put together a lot of cords and generator and not grounding them. And just I don't want to be responsible for anybody's death. So I decided.
Yeah, I'm actually glad that you mentioned the electrical safety end of it, because beekeepers, they have to treat their bees, they have to treat their hives, and they have a tendency to go out there early in the morning when the grass is still wet with dew. And I think you're right. They'll run extension cords out there, make the connections. They're not waterproof connections. So not only have you made a very convenient battery-powered unit, which will go anywhere without an electrical source, without an inverter, and without all the other things that people have come to do, but you've eliminated the potential for electric shock based on dragging a hot cord through wet surfaces. Also, if it starts to sprinkle or rain or something, you don't have to gather up a wet cord, by the way. You've got do you have one with you? Do you have your unit? So just because some people may be looking at this video and wondering, what do they look like? This is what we're talking about now. And of course, it has a connection on the bottom. My particular version is a DeWalt, and it says that right here. And so what we've heard described also is basically that this is bulked up a little bit, so it's not as responsive to environmental extremes, so cold or hot. So, for example, I live in the snow belt in the state of Pennsylvania in the United States. And we're coming up on our lowest brood of the year at the end of this month. So something like this would retain its heat better in cooler temps without having to constantly require reheating as another unit might, or what's the story?
The heated bowl is completely insulated around with ceramic insulation. So that's what you can see when you kind of look next to the outlet spout. So it does use about 10 to 15 percentage more energy when it is cold because anything has temperature loss.
Right,
But any breeze or any I used it even in minus degrees just to test it, and it was not clogging. It was not causing any issues if
right,
the wood was dry when I was using it. If it was soaked with water and I used it through a hole, it does cool down. You cannot do it. It's just physics.
right.
But if your wood is dry, you can treat 100 hives and it will not have the clogging issue.
Mm-hmm. Yeah, and that test is extreme because we wouldn't be delivering oxalic acid when your colonies are clustered tight anyway. So that's a
No.
great parameter to understand what the response will be with the unit that you've developed, but it's going above and beyond what normal
Mhm.
beekeepers hopefully are going to expose it to.
So
So,
one of the things I did, you asked about, is I'm not heating the side like with a clamp heater, but I'm heating the bottom of it where the temperature is thrown away, and that makes it very responsive. The second thing is uh, pretty much all the vaporizers are using this soft copper tube, which they bend 2 times, and that causes a couple of issues. One of them is the gas is slowing down where it is bent, and it is again on the outside of the device, so the breeze can more reach it and can cool it down, and that can cause a lot of issues when you want to treat your hives. It's just they are flying, it's just 10 plus degrees or 50 plus in US, and then you have these clogging issues. So what I do, I use a special design, and I managed to use a straight cross tube, which is thicker on the inside, which is inside the vaporizer, and the one on the outside is 6 millimeter, just the size which they got used to using, but it is able to carry the 12 volt, 12 amp hour battery plus the weight of the design, the device through a hole. So you can pretty much uh, don't need to worry about, the outlet tube or the spout being bent. And in case anything happens there, you don't need to throw away your device or do a lot of repair, but you can just unscrew it with an M8 screw. You just clamp it with a plier and open it, and you can put in the new one, which you can order and doesn't cost much. So it's uh, that was really a crucial issue, that it has to be on the bottom so you can use it through the entrance. It has to be straight. It has to be short so it is not clogging. It has to be from a strong material, and it has to keep the temperature well. So all these things was a crucial part of the device, that, and it also cannot be on the top because then it is far away from the heating. So it has to be on the bottom, close to the heating, so it is not cooling down. And once I figured these out, and the heating and then the temperature control, which is pretty much just using the pit function and figuring out which is the best setting. Some of these pit controllers has self-tuning capacity where they learn the physics of that material which they're heating up, and once they figure it out a couple of cycles, then they just follow that cycle and it will not overheat. So, and then it was all about insulating everything, and which was really, really hard is to forget whatever I have seen on the market and to come up with my own design. So that was really, I was struggling with that for a month, just to figure out, and I always copied that version where you have the cup separately and you've got the electronics separately, and then somehow you had to get the wires to the electronics, and it was a big struggle. And the main problem I had is servicing. So I wanted to make a device which can be disassembled in 5 to 10 minutes, and everything can be reached and then put together back. And this also helps the manufacturing, because if it's easy to service, it's easy to manufacture. So I remember when it was like a really, really happy day when I had this idea of everything putting together in one body, which makes it simple, which makes it easier to protect it from water and so on. So, and then the challenge came how to stop the heat to go to the back where you've got the electronics and the pit control and so on. And I have some extra walls inside, so, and then some ventilation holes, so it is like stopping the spread of heat to the back.
And I should mention, by the way, if anybody's looking at this right now, like laurabees.com is the American company that is selling these here. I paid full price for mine, by the way. He didn't give me one. So it's I put my money where my mouth is on this.
Yes, indeed.
Yeah. So you did hit on something that I want to talk a little bit about, because somebody may be wondering. Initially, when you talked about some of the early equipment for oxalic acid sublimation, the temperature went too high and altered the gases that were coming out, rendering it ineffective for the treatment of the mites. The byproducts of an overheated oxalic could be a concern. Can you talk a little bit more about the importance of controlling the parameters for a proper sublimation process, and what might happen if it's too hot, for example? How did you determine that?
Well, it is a interesting topic, because I looked up everything in English and in Hungarian and so on to look, what is the optimum temperature. And when I looked at the designs on the market and I tested them, I understood that some people are talking about, like how low you should vaporize, but at the same time, everybody is pretty much using the same range of temperatures, around 230-ish, at least the settings, whatever it is, like overheating and cooling down. But it was more about the design of the tool where it is not clogging. So pretty much the parameter which they used. And I tried to see whether anybody did some experiments, not too much about, which is effective, because these tools are all over the place with the temperatures. So it's really hard to do a proper test with beehives, which is the effective temperature, because and I looked at, like some research papers which universities did, the effectiveness of oxalic acid vaporization. And I was troubled that a lot of times they didn't even specify the temperature which they was using. Some of them just specified the tool they were using. And they only looked at, how many oxalic acid you have to apply to get a certain, efficiency out of the, like mite drop and so on, and mite load drop and so on. So nobody really, as far as I know, and maybe I'm wrong, then I'm happy to be corrected on this, but I didn't see any data where they actually not only looked up the data of the oxalic acid and they said like 157 degrees, it starts to sublimate or vaporize, as they say usually in England or USA. And then at 189-ish temperature, it starts to decompose into different materials, like formic acid first, and then carbon monoxide and carbon dioxide, and then some other gases. So it was really only these data from the dictionary, so to say, like chemical dictionaries, but I didn't see any experiments being done. And when I kind of had the good device, which was not overheating, not cooling down too much, and I saw that I can vaporize at 200 degrees, I can vaporize at 300 degrees, but the temperature, the fastness of the vaporization was huge. So like if you just vaporize at 200 degrees, which is like I know that a lot of, so 200 degrees is 392 Fahrenheit. If you vaporize on that, it's about 45 to 50 seconds for 2 grams. So it really becomes slow. And only 30 degrees higher, which is like 445 Fahrenheit, then it drops down to about 18 to 25 seconds. So pretty much halvens the amount of time you need. And definitely commercial beekeepers don't want to stand there for minutes to perform this task, especially if they do like several treatments, if it's not a broodless period. So it was really kind of making me curious, what is the optimum temperature? And I had two ideas. One of them was you really have to go down with the temperature uh, and as low as possible to to get close to that 189 degrees, and then that really solves the problem. Or maybe we have to go a bit higher, and the fastness of the vaporization kind of limits the degradation or the decomposition of the material. So I just didn't know which is the good answer, and even if I was really, really busy, in spring, that's what I started to investigate of, chemically to test what is coming out and what is the efficiency of the tool at different temperatures.
And I have a question about the oxalates that you use. Does your government control what kind of oxalic acid you can use? Do you have to use apibioxal?
As
Can you
far
use
as I
anything?
just,
What are the requirements?
just recently, I got to know that officially that's what is allowed, epibioxal in Hungary as well. But the government and all the agencies, working in beekeeping, they are not really strict about that. So they know that it's like not really a good rule, and the people are not really using that for vaporization because of the uh, content of epibioxal, which has glucose in it, which caramelize and so on. So it has some additional ingredients which are not really good for the vaporization. So it's like really, I think, a very shame that uh, we can use vaporization, but they don't allow to use the pure oxalic acid, which is the best because we don't want to add anything to the hive, which is not necessary for killing the mites, as little extra material as possible. So I even thought about, making these tablets, and I contacted some companies regarding that. First, I thought that's a good direction, and they said they have to add some ingredients to make a tablet easily. And I right away stopped that pursuit because I didn't like the idea of bringing in any new, material being warmed up and vaporized into the hive.
Yeah, because a tablet needs some kind of binder to
Yes.
hold its form. And you're the first one that's mentioned, so let's talk about this again real quick. The apibioxal, because it's not a 99% pure. I think it's like 94 or something, right?
Yeah.
And so this added material that's with that, it's not that that's negative for the bees. It may gum up the delivery system.
Well, I don't like the idea of having anything there which is not necessary, because definitely not good for the bees. I mean, caramelizing like glucose is so I don't know, but I don't like the idea of smoking anything which is not necessary. The other thing is that more residue remains in the cup or in the bowl, and that means that you have to clean it more frequently. And also, it's not enough just to clean it with clean water, but sometimes you have to put in water and then boil it up, let it boil up, so that it kind of cleans out more perfectly the bowl. And that is just, like doing that every 50 hives is not feasible. And so I know by experience that people don't use that, only very few of them.
So why is it there? Why did that become the approved formula?
I guess that when they proved that it was more for the dripping, it was more for the other method, not for the
For the
vaporization.
dribble. So
Yes.
the dribble method.
And there it's not a problem to have glucose in it because bees are just licking it up. It was more for that, and then they turned, because it's like slow, you have to open the hive, you can only do that once in a generation of in a generation of bees. It is so and that is usually only used for fall treatment. So I think since then nobody kind of pushed it, because it's a lot of money and time to get it certified.
Approved, yeah. So I'm wondering if when the United States adopted oxalic acid as an approved method as a miticide, if they just went with an already established procedure from another country that was already approved and using it.
I
And
guess so, but I don't know.
yeah, it's very interesting. It's something that we really need to look at, I think, because as you mentioned or alluded to already, I think a lot of beekeepers just use the purest OA they can find, even though we have a requirement here to follow labeling and it's a miticide. And so we have to be responsible and say that they have to go with labeled treatments here, at least in the US. But I question that myself because when it first was approved, I ran out and found 99.1% pure oxalic acid. And like everyone else, I thought, whoa, it's more pure. I'm going to use it. And I had a great mite drop. So I wonder if even there's a difference in efficacy for the mites, apabioxol compared to, have you done that testing?
No, but I am 100% sure myself, so I may be wrong, but just my logic tells me that the purer oxalic acid I use, the better. Not like, I wouldn't say that it's less efficient when it's like 94% or 99, because you've got that most of the oxalic acid is just heckled to deal with that in the device if you have a lot of residue.
Mm-hmm. And you know, I have a problem. I use apabioxol and it's so dry. You can see how used kind of this is, but it's so dry that it won't load into this.
Yes, yes, it's just too dry. You can maybe just open it up a little bit so it's sucks some water from the air. No,
yeah, leave it
humidity.
open so it's exposed to humidity. Yeah.
Yes.
Yeah, it's too bad the tablets have to have stud added. So for those that are listening too, I think please don't jump on the convenience of tablets because there may be stuff in there won't be good for the unit.
Tablets, you can make the tablets just from the, pure oxalic acid. That's not a problem.
Mm-hmm.
You cannot do it commercially because those tools are applying a lot of pressure. I mean, those presses, and if they apply that, they actually push out most of the water and they have to put in something else to bind it. So that's one thing. The other thing is that after I did some experiments, it's not the good direction, I think. I mean, for hobbyist beekeepers, maybe, but not even now after we have such a good dispenser system. But previously, if you apply that, it takes some time till that tablet dissolves, till that breaks apart. And that is like another 20-30% of time. And why have that when it's not necessary? And then you are playing around with the tablet, or you buy it, and they usually then charge you several times the cost of the pure oxalic acid just in a bag. So it's like yeah, that was the other big challenge of making a dispenser which is working great, which is adjustable, because beekeepers always have their best choice of what is the best quantity and so on. And I left it to the end, and I remember I was at a meeting with my company, like an internal meeting, and it was very boring about COVID issues and so on. So I was drawing it up, and I knew that once I figured it out, that should be the design, and that was only very small changes after that.
Oh yeah, it's your delivery system, because just so people can see, it's set up so that you have 1 gram, 2, 3, and all the way up to 4 grams if it's full. So that covers the full range of your treatment levels. I don't know if anyone is using just 1 gram for a treatment.
You can use that for very small nucleus, but it's not. I usually recommend actually 2, and that's one of the big problem I encountered, that in Europe and in Hungary, I would say 90% of the people are using 2 gram, and they are not using 4 grams and so on. What I recognized is that people in US, and for some reason, which is like some researchers giving out, like their opinions and some, their material on that, they use rather 4 grams or even more than that. I hear some people are, can you load 8 grams? And I said, why would you do that? And, like I read that's what I have to apply. And that was the other thing which kind of made me think a lot, why they have to use more than we use, or why do they use it, or what went wrong with the research, or so this was like a lot troubling me, that partly because if you use a lot of like 4 grams or 8 grams, that means you halfen, or you will use much more battery amp hour for the same amount of hives. If you go to double the quantity, like 4 grams, you have to use double the amount of batteries. It's that simple, and it becomes less feasible. So it was like I really wanted to see, first of all, what effect the tool has in efficiency, and what the oxalic acid itself. Yeah.
So what's the oxalic acid dose that you found to be effective for you and your hives?
I personally use 2 grams, sometimes kind of just for my good feeling. I put in 2.5 grams, but I don't go higher than that. And in the last 4 years, I only used oxalic acid to treat my hives. And like I went into, and I had no losses since I use oxalic acid. So in the last 4 years, and I only have like now 18 hives or 19 hives. So it's not like I'm just a hobbyist backyard beekeeper, but that already gives me sufficient, job, and it's a hobby for me. I don't want to do it as a profession, because it loses that good feeling, that I enjoy it as I
Yeah,
am
it's
doing
not
it.
fun. If you have to make money, changes how you approach bees. What are the hive designs that you keep there?
I use the horizontal one,
Oh, you
and I'm
do?
thinking about changing that. Yeah, and it's not a. It's, I think, good to start with. Maybe in Hungary, like a lot of people are using that, but more and more are using the what you use in US. When you put on each other the hives.
The
It
Langstrom.
makes more sense when you are commercial to do that. You can use easier the queen excluder. You can just take off the supers. I mean, there are a lot of advantages for that other design. And actually, when I got really, really busy this summer with my manufacturing of this vaporizer, I was really thinking whether I should sell most of my bees and start with a new version. And what stopped me is that I want to continue doing some more experiments as much as I can. So I didn't want to do that, even if it's really hurting to extract the honey and so on when I'm so busy with other things. But I decided that slowly I will change over, and at least I will test some of my hives will be a different design, and then see how it goes, because I have to spend like pretty much 2 days to extract honey if they are full, just 18, 19 hives, and that is like too much. I think that's not feasible, even for a hobbyist beekeeper, to have so many holidays spent just on, it's not ideal.
So when you mention a horizontal hive, there's a lot of different formats even for that. Is it a lay-ins, or is it a top bar hive, or is it a long Langstroth hive, or?
It has its own name in Hungary. We call it the Nagybocsonádi. So the frame is quite the honey frames are quite big, and I have 18 frames in it, but some of them has 24, and so I don't know in English what's the name of that. Sorry.
Do you have any videos showing this hive design?
Yeah, definitely. You can look it up on the internet. I can send maybe the name of
But
it, and then
have you made any in your own?
in my presentation, I did not include that. No.
You didn't include your backyard.
No.
Okay, and for those also who are listening and watching, the links to the website will be down below. Some other information will also be in the video description, describing what happens when we decompose oxalic acid at too high a temperature, and we have some studies that we can give you so you can read those. And it's very interesting. Yeah, so the method of extracting honey is just too much work with these horizontal, but you're going to stay with horizontal hives, you're thinking?
What I'm thinking is I want to make some observation hives.
Okay. Yep.
I'm really interested in another topic in beekeeping, and I want to pursue that as a development. And for that, I will see. It's not really about money for me, the beekeeping, it's hobby. So it doesn't have to be very efficient. I was extremely busy in spring and in summertime, but by now I had to understand I can't do it alone in the garage. So I had to rent a place. I had to get, people full-time working on this, and 5 of us now manufactures, they manufacture it, and I do all the other work which I have to do, and the quality assurance and development and so on. So I knew that if I'm stuck in the garage and just trying to survive, I'm gonna have no time for further development and so on. And that's what I really like. It's not the manufacturing part, although kind of I like the challenges, but not the everyday work. You always have quality issues, suppliers complaining and so on. It's just something I have to do, but it's not my fun.
And we mentioned, like I showed the DeWalt battery here, but this has compatibility with a bunch of different kind of broadly available battery packs that are used with other power tools. And so we'll link your website for that, and you probably have listed compatible batteries there.
Yeah, like Bosch, Makita, Enhel, DeWalt, Parkside, and Milwaukee, and something like 7 different types. Yes.
So very good chance if you've got battery powered tools that you'll have a battery that'll match up. Now, you had some supply issues this year where people weren't able to buy them. They were out of stock. Do you foresee not having supply chain issues, or?
I had no problem with supply chain. It was more about bottleneck in production. So I could only assemble a certain amount of devices, and to scale up, if I do it too fast, that will be not good for the quality. So I had to find the right person for the assembly. I had to train them. I had to set up production papers, and then I also had to educate my suppliers so that we all know what is critical and what is not critical in quality. Like there's no point of like making shiny something inside, which is like not even visible to the eye. So it was all a challenge of ramping up. I started it in April. I was still selling like less than 100 a month, and I could manage that alone, even if it was like quite busy. But then once Rob came into the picture, and it was really I was very much seeking out someone who is not only like wanting to make a business, but understands this market, understands the vaporization, can give support to people, and can do the maintenance. So I wanted someone who can really be a person being there for the customers, and that took some time. And I remember actually Rob was developing his own battery version, maybe because of his, he saw my design, and he's like a very genuine person. He didn't try to just steal the idea. He didn't even try to buy it. He was just working out his own version, and I think he managed something like a dozen treatment from a 5 amp hour battery, and with 2 grams. And I really like his approach, how he's doing his videos about it, and how people appreciate his support with his own, like corded device. And I tried to call him and write to him. He didn't reply. Once he picked up the phone.
Oh, really? He never replied?
Yeah. He was just not available. And he picked up the phone and said, I appreciate it, but I love developing, and I love the fact that it's US made, and I'm not interested. And I said, let me just give you some advice what you're doing wrong. And I tried to explain to him how he can make it like around 4 or 5 times more efficient, his tool. And he is like an engineer, I don't know, as a degree, or at least his blood is like the blood of an engineer. And myself, so we really understood each other, and I think we had like an hour-long conversation, and I got him interested and sent him a sample to test, and he fell in love with it.
Good. Yeah, I'm glad that Rob at Laura Bees, so that link will of course be down in the description also. But yeah, I think that's going to completely eclipse his plug-in version that he was marketing at Hive Life conference last year and everything. I have one of those also, but the battery pack is just so convenient. Even though it's a much more expensive unit, you're going to save time. You're going to, in fact, I have another take on that, other than the safety that we described too. But I think when it's complex to set up and people have to run wiring and everything out, I think they don't treat when they're supposed to. I think if it's more convenient and ready to go, they're going to treat when the bees need it. I think the more that's involved in the setup and the power source and everything else, the less likely people are to keep up with their varroa mite treatments when it comes to sublimation. So I
Completely
think
agree.
that's, yeah, I think that's really good. Glad Rob's on board. And yeah, that's going to be, I guess that's probably going to be his business too. So I have another question for you. A lot of people here have plastic hives. They have them made out of polystyrene. They're the Apame hives that are made out of plastic. And because there's so much heat here, Laura Bees has a little sleeve that goes over the top of this. I believe it's Teflon or something. What
It
do
is.
you recommend people insulate this with so they can treat a polystyrene or a Apame
Yeah,
hive, for example?
I just saw whether I have it on me. I already am developing a full system. So what I recommend, and I will have it on my webpage soon, I already have like 100 from each of them, different designs, is the easiest thing to use is not Teflon because that is like over time it gets loose, or if it's very tight, it's hard to get it off. The other thing
Okay.
is it's expensive, and what is better, I think, is silicon. So you can buy silicon which is uh, able to survive temperatures up to 315 degrees
Mm-hmm.
Celsius,
Mm-hmm.
and you only get there about less than 200, so it's well within the safety limit. And
Mm-hmm.
there are many different designs, and what I worked out, I will have like things which you can just plug in the two ends. So if you put in water, you can plug it in and you can shake it and it's easy to clean. The other thing is that if you have different hive sites, like apiary sites,
Mm-hmm.
then you can just plug the two ends and you can put it into a wooden box and go to the next place and don't worry, not worry about having any oxalic acid fume within your car. So that's,
Right.
I think, something which I'm working on, and I already have it. I just didn't have time to put it up on the webpage. And the third thing is, if you use silicon, it's very easy to pull it off, to put it back, and to apply the different types.
Mm-hmm.
So I will have those available very soon, and Rob is already testing them, and I think that will
Yeah.
be the direction.
And he mentioned what you already said, I believe, that the Teflon, the little sleeves that go on, they have a tendency to
Yes,
bind onto the tip. So then if you're trying to go back to wooden hives or something.
yeah. I actually invested into a design, and that what it does, and this is something I want to. I only have about uh, 20 samples. So what it does, I will not pull it on, you can actually slide it on the 25 millimeter stainless steel tube, and it
Okay.
creates a cup around it. So it has like several advantages. One of them is that any excess oxalic acid from the side of the dispenser falls into that, and it is not messing up your device. The
Yeah.
second thing, it insulates the top, which is the hottest part, and that's where you lose the most heat. And the third part is that you can fill up like 30 hives worth of oxalic acid there, so like 60 grams.
Oh, and then
And
you would just stick it in that. Okay.
and
Yeah.
if you're a commercial beekeeper, you just have two devices you can treat at the same time, and you
Yeah.
don't need to go up with your hand to the box and go back, go up, go back.
Yeah. Yeah.
But everything is there close and handy. So I'm working out the final design there, and hopefully by spring I will have that as an accessory, which I think will be wonderful because your device will keep clean, it will use less battery, and everything will be there. And
That's very interesting. And yeah, I have little bits of oxalic acid on top of mine, so I guess I'm sloppy.
oh
So,
no, it's
but I
just
do, but I do have a question too. This O-ring up here.
yes.
What do you recommend for lubrication on that?
First of all, after the use, this dispenser can be just put into a bucket of water. You can shake there like couple of times, and any excess, anything inside will just be cleaned out. So that's the first thing. And
Okay.
secondly, any grease or oil which is not organic, so not like sunflower oil, because that will dry out eventually, and that
Right.
will
Okay.
reverse what you want. So you have to use like mineral oil or some kind of oil or grease, just a drop, and that will help a lot. Not too
Okay.
much about the lifetime, but like it will be really easy to put it back and pull it out.
Okay. Yeah, that's true. And so silicone grease maybe would be okay?
Perfect.
Okay.
Perfect.
Good.
It doesn't get too hot on the top, so it's like
Right.
it's not even. I could have used there like very special O-rings, but it's not necessary because it doesn't get like not even 80 degrees there.
Yeah. And well, I was just wondering because 2 spare O-rings came with the unit, so I didn't
Yes.
know if they, so what's the longevity? How long do they last?
I never had to change it yet, and nobody complained
Okay.
that they had to change. So I think
Okay.
it lasts for
So we
long.
just have them. We have the extra ones
It
just
it
just
costs
in
so little money that I don't
case.
want people to, to shipping costs would be 20 times more than the price of the
Yeah.
O-ring. So I decided to add
Yeah.
it as convenience.
Okay. So any special tips or tricks that people should know if they get one and how they use it? Any like based on customer feedback? Has anyone had problems? My tube is not clogged once, but then I'm not doing 100 hives at a time.
Mhm.
So any reports on clogging of the tube or any maintenance issues?
Maintenance wise, so a couple of issues, kind of I'm summarizing what problems they had. One of them was that they complained that it is not warming up. It stops at around the boiling temperature at 100 degrees. And I was really worried because not one, but several person contacted me at a similar time rate. And I asked them to return it back. And one of them just had some water within the cup, within the bowl. And that, as long as it is not, because after it just remained there after the previous use, after he cleaned it out.
Mm-hmm.
And it is boiling at 100 degrees and it is staying there until it is completely boiled out. So
Mm-hmm.
that was one of the issues. The other issue was that some beekeeper just soaked it in water. So the insulation got wet
Oh,
and that stopped it for insulating, and that actually was cooling it down, and it was only
yeah,
warming up to about 115. So you should only get
yeah,
water within the tube and nothing on the outside.
yeah.
Third issue was, and this is not too much like maintenance, but uh, yeah, I speak first about something else. So it was that if they use it, like I had an old person calling me, he used it for 1,200 hives, like over several weeks. And then the problem he had was that it started to be slow. So if the oxalic acid dropped in, nothing happened for a couple of seconds, and then the temperature started to drop. And what happens there is that there's a coating inside the bowl from the residue. And if that coating, what it does, it's like it's not spreading out the oxalic acid. It takes time till it spreads out and starts to cool it down. So the solution for that is to put in some water, not much, like really like a quarter of a deciliter or something like that, and let it warm up by the battery and steam out everything, and that cleans it. So that perfectly solves that. So it's not enough to just wash
Hmm.
it. From time to time, you have to steam it out with warming it up until everything is boiled out with some water. And the next thing which I recognize is that some people are just drilling a hole on the back of the hive, and they vaporize on the frame. So
Oh, they
the
run it right
start,
up against the
yes,
frame. Yeah.
and that is not clogging the device if there is big enough distance. But what happens there is that oxalic acid deposits on that surface and crystallizes back, and it will not spread out, and it will not be an efficient treatment. So that's something to keep in mind.
Mm-hmm.
And even if they use it through the entrance, if it's not a bottom entrance, but like a middle entrance, and usually they put the entrance there, so it is facing the frame where it is already like a closed frame, so
Mm-hmm.
less access for the wasps and so on. That is also not very ideal because you are fuming it on or gassing it on a cold surface, and like maybe 50% of the oxalic acid will just deposit on that
Yeah,
surface.
it condensates right there. Yeah.
So either on the top you have to vaporize, or under the frames, which is much better, or if it's a bottom entrance, you can do it through the entrance. So these are a couple of these issues they have to follow, but otherwise it does the job.
Well, I'm glad I asked that question. That's very helpful. And is there anything else that you want to tell us that we haven't covered so far?
Maybe one thing, just I will forget it. One of the crucial things with battery is that you should not over discharge. And if you discharge it below 15 volts, these lithium ion batteries like 18 volts versions, that really kills your battery. You can kill it in one use if it goes down to 10 volts, or the device switches off if there is no protection in it at 8.5 volts. So that's when the controller doesn't have enough power. So this is something very crucial.
That'll read on the top right here.
Yes.
Voltage, right? Okay.
But what I kind of was working hard on the last couple of months is to come up with a circuit which cuts off everything and protects the battery. So very soon I will ship like that to you as the devices that I protect the battery.
Yeah. Okay.
They cannot fail it. So I
So
already
a low
have
battery, low voltage cutout is what it will be.
Yes. Yeah. The design is like finalizing. It's like 15.4 volts, because that's like 95% already discharged, and I don't want to fully discharge. It's like only one extra vapor, treatment is left there, and that really protects. I had some customers doing it commercially, like on 1,000 hives and so on, and the problem they had, they hired people for that. They hire simple people, and it's just having the mask on, fogging, sunshine, it's hard to read. And inevitably, they destroyed some of the batteries and damaged them. And I already wanted to do this in March, but because of all kinds of shortages of ICs and so on, it was very hard to make a stock from components so that I'm not running out and I can safely launch it without being ashamed, like 2 weeks later I cannot ship it and I have to go back to the original simple design. But I still will keep the voltage meter so that people can track how much power they still left in the battery. And it's interesting that kind of sometimes confuses them that because the device is switching on off the heating frequently as it is approaching the set temperature, what you can see on the voltage meter is that it is up, down, up, down, up, down. Right. And that is actually just the load. If you apply that 14 amps on the battery, the voltage will drop about 1 volt. If you remove that load, it will increase. And the load, so you have to monitor the voltage when it is under load, and that's where it shouldn't go under 15 volts.
Okay, so 15 volts is the cutout, and if you go lower than that, you risk damaging your battery.
Indeed.
Okay. Excellent. Anything else?
No, I think I will tell all else in the presentation.
Okay.
Okay. So what I did in May and in June, I did some experiments on how I can measure what is coming out from the device, and then measuring, the acid content of it and so on. So that's what we will be talking about. We already mentioned that the water starts to boil at 100 degrees, which is like 212 Fahrenheit. And as the temperature increases, then you start to vaporize or sublimate at 157.5 degrees. And if the temperature goes above 189, then you start to decompose the oxalic acid into different things like carbon dioxide, formic acid, carbon dioxide, water, and so on. So it's like decomposes into different ingredients. And but what happens, we are not just warming up the oxalic acid, but we already put it into a place where there's a lot of heat. And then everything happens at the same time. It starts to boil instantly, like within a second, and it starts to vaporize as well. And then probably as the time goes, then more and more oxalic acid vapor comes out. And then also some decomposition definitely happens. So I looked at, on the internet, what is the recommended temperature, and I was I was having contacts from Greece, and they said that they vaporize at 270 degrees, and I was shocked. And they said it is working, which kind of I questioned that definitely, and they asked me, whether they can set the device to that temperature, and I said, it's possible, but I limit it at 240, so it's not really I can change that limit, but I wanted to understand why do they want to do that. And some people are recommending 200, some 180, but then it takes for ages. So, but I didn't find any studies on that. So my goal is to make experiments or measurements where we can see which is the most optimum temperature for vaporizing our mites. And I talked about this, how the temperature is regulated with the devices which use clamp heaters. So they never kind of stay the temperature which is set, but they regulate a lot. And you can see here, like I measured it every second, the temperature, and you can see how it is warming up, but going up to 262 degrees, which is like 500 plus Fahrenheit, and then cools down and then switches on and cools down. So that's why I think nobody really pursued this direction, because they just wanted to survive and not having clogging issues. But that was all. And yes, we know that it should be lower temperature, but this is where we survive, and it is kind of working. So I kind of went into the design, and we already talked about it. I'm heating up the bottom of the bowl, so that's where the heat is drawn away. I use not just on-off, but peak temperature control. And for that, you cannot just use a relay, but you have to use a solid state relay, which is like a MOSFET transistor, which is switching on-off the heating without any moving contacts. So you can switch it on-off like 10 times a second and doesn't cause any issues with the electronics. But if you use the traditional clicking relays, then that will fail very fast if you start using peak control. We talked about a low position spout, and it has to keep hot, so it is not clogging. And actually, it has to keep hotter than 157 degrees, because that's when, if you go under, it starts to crystallize back. So that's when it starts to vaporize, it sublimate. But if you go colder, then it will start to crystallize back. So the tip of the spout or the outlet tube has to be hotter than that. And it has to be strong enough to support the weight of the device, not to break, and the full device has to be insulated. So after doing all this became the result. So the device warms up, and then it stays at the temperature which is set, not overshooting. You can see that the last 5 to 7 degrees is like slowing it down. That's when it starts to switch on off, and more frequently as it is approaching the set temperature, and only adding as much energy as needed for the keeping of the required temperature. And when I drop into 2 grams, it cools down very fast, but right away goes back within 30 seconds. So you're ready for the next hive, and you can go on, and you can see that it's very repeatable. So it's not like all over the place, but if you use the same amount of quantity of oxalic acid at the same ambient of temperature, you will have a very repeatable temperature curve occurring. And these were like 17 of my hives vaporized, and I was measuring it, so it was like actual cycles I was going through my hives. We talked about the dispenser. So it's just good that you can set up whatever quantity you want, and you can go ahead. So then now we can accurately control the temperature. We can accurately control the amount of oxalic acid we put in. And the question came up, how I can collect the oxalic acid vapor, and then how I can measure that what is coming out. And that was like a very challenging thing, and I had to think a lot and do some experiments. And then I came up with this solution. And just interrupt me whenever you want if you have any question.
Okay.
So what I do here is like I have a plastic tube and I've got a copper tube inside, just like here on the bottom, and I have water there and 245 degrees, on the two ends, so the water keeps in, but the copper is being cooled down constantly. So that way, when I use, you can see here, I'm using like a silicon cone-shaped additional part. I can completely seal the copper and I can vaporize inside this copper. And you can see here actually what happens. You have all the crystals depositing inside the wall of that copper because it's cold. Once it is cold, everything is condensing there and crystallizes back. And the end is completely open, not sealed, because then you have a pressure which cannot come out, so it will shoot back the dispenser. But because it's open, everything cools down, but nothing comes out on the end, and everything remains inside this copper tube. So once I have that, I can, after the vaporization, I can plug in the two ends, pull it out, put in some distilled water, shake it, upside down all the time, so it like really cleans it out, dissolves everything inside, and I can do these samples with different temperatures. So what I did, I was tracking the temperature every second. I was measuring the oxalic acid, what I put in, so like the empty and the full, and then the empty, and from that I could work back exactly, what quantity of oxalic acid went into the bowl, and so I could like track everything, and this is all the measurements I did from 200 to 300 degrees, which is like 392 Fahrenheit to 572, every 10 Celsius degrees. And you can see how repeatable it is, like constant, dropping down, and then slowly going back to the original temperature. And it doesn't really matter if it's at, like 300 degrees or 200, it does the same. So, and then I have two friends, like a couple who is chemical engineers. They work in labs, and we worked, not we, but they understand it. So what they did the measurements, they did the acid-base titration. They measured the acid content of whatever I washed out into that 100 milliliter distilled water. And very, very accurately, so like one extra drop of this colored solution will change the full color of the sample, and you can see exactly, you can read back and you can calculate what is the acid content. And then here are the kind of in the kitchen we did all these experiments, and then came out the result. And I want to ask you first, what would be your guess? What is the result? So like at 200 degrees, at 230, and maybe at 300. So what would you guess of how the acid content is changing? Or do you have a guess?
No.
No, you are safe. Anyway, this is the result, and we actually repeated every measurement 2 times. So it's and they came back always the same result, like within 1% of accuracy. So I'm quite confident of the result. Only we have to understand it in the right way. So first of all, I have to emphasize that I am assuming something when I have this. What I assume is that I only have oxalic acid there, but I might have, and I definitely have some formic acid there at the higher temperatures. So I have to assume that because I cannot differentiate with this measurement between oxalic acid and formic acid. And so this is the best case scenario, let's say, that you only have oxalic acid, and this is the curve which came out. So at 200 degrees, which is like 392 Fahrenheit, only 32% of the initial quantity came out, which is like, it was shocking to me. I was expecting there the highest, like 90% or something like that. And only 32%. So if you have like 2 grams, 0.6 gram is coming out on the spout. So we are complying with the 1 gram recommendation because it is less than that. But as we are going up to 230 degrees, it is already increasing above 50%, so like 50.6%. And then it goes up to 68%. And when I saw this result, I emphasize here that maybe you have here like more and more formic acid, sorry. We don't know. This measurement was not able to distinguish. I'm working on finding universities and like research centers where they can differentiate and we can repeat the experiment. I haven't been able to. Just like tomorrow I will have a discussion with a professor at a university whether they can do it in their labs or not. It's possible to do that. I know that because these chemical engineers said that they could do that in their workplace. It's just not allowed because they deal with medicine and it's not allowed to bring in anything. But it would be really, really crucial to figure it out. What is the percentage of the ratio between formic and oxalic acid at different temperatures? Because now we can collect the vapor and then it's just simple measurement and we can track that and we can make some proof measurements, and that would be like, I think, very, very beneficial for beekeeping industry to figure it out once and for all what is the optimum temperature. But what we can kind of see is that as we are increasing the temperature, the time it takes to vaporize shortens considerably. So you can see here that to vaporize at 200 degrees, it takes around 40 to 50 seconds, rather 50. So it already went up to 200 degrees and it stayed there for about 10 seconds when it stopped the smoke coming out, because I did this experiment also in air just to see the amount of time it takes to vaporize. When you do it at 300 degrees, it takes like 10 to 15 seconds. And so my understanding is that if you go up with the temperature, then it takes shorter to vaporize. It is a faster process, and it doesn't have enough time to degrade or to decompose into different material. So that's why you get more and more acid content as you are going up. And it makes sense if we understand it this way, but if we get here like 20% formic acid, and that affects our brood and affects our queen, and we don't want to do that. So it's definitely, I'm not recommending, I have to highlight, I'm not recommending to go above 230 degrees yet, because we don't know. It's just, it would be foolishness, but it's something we have to do some more experiments and actual measurements and ratio, and maybe what ends up is that whatever decomposes into formic acid decomposes further into carbon dioxide and carbon monoxide and doesn't stay there. My guess is that it's not like at 300 degrees you get like 80% formic acid, because it just doesn't have enough time to decompose. But I may be wrong there. It's just something we have to kind of stop guessing and start doing some actual measurements. So what I understand is that the surface area of the bowl affects the decomposition rate, the quantity of oxalic acid, because more oxalic acid lowers the temperature more. That will be more temperature drop. That will affect the overall temperature where the vaporization happens. Because when you look at this, in the initial like 5 seconds, it's like most of it is just crystal water. The temperature is not there yet to vaporize. And then as the full, the temperature there rises, then the oxalic acid starts to go out. So really, when I say like 200, it is actually 190. When I say 300, it is actually 290, like 10 degrees lower. But I had to kind of compare it to the set temperature. So I'm just, sorry, going back here. The other thing is the set temperature and the temperature drop. So what kind of heating you have, does it drop a lot? And that affects the length of time it takes to sublimate. So all these variables are affecting the time, and that affects how much will decompose into different material. And what is interesting here is, like, if I compare with just a clamp design of Vaporizer, this is what your temperature is like changing. When you put in 4 grams, your temperature drops down to around 190, 195 degrees, and that's where the vaporization happens. And then it goes back slowly and overheats again, even more, because it was heating longer. So if it is heating longer, that mass heats up more on the side, and that will overshoot the bottom as well, where the temperature probe is. So that's where I'm really encouraging these measurements, because what I see is that, and from this you can understand that if you use 2 grams and it's breeze, there's a little bit of breeze, it's 10 degrees ambient or 50 degrees Fahrenheit on the outside, your temperature drops a lot more. It struggles to go back to the original, and that will maybe only like 25 or 30% efficacy you get out. But if it's a hot weather, like it overheats, like summertime, you may get like 50 or 60% efficacy because it is overheating. And we don't know if it introduces formic acid or not. It's an unknown yet, but definitely the efficacy is changing. And then if you put in 4 grams, because it is not working, because you had the experience in summertime or in winter time that the 2 grams was not enough, you put in 4 grams, what happens is that your temperature is dropping back even more, and your overall efficiency gets even lower. So you are fooling yourself, and you think that, oh, I have to apply 4. No, I have to apply 8 grams. And you are constantly lowering your efficiency, overall efficiency of your tool. And it's just fooling ourselves. We have to have a good device, which is not cooling down too much. And then we have to do measurements with that device. And then we have to come up with the right quantity, which does the job at the right temperature. And then we know that we are doing what we are supposed to do, and it's not changing all over the place. Because if you put in the oxalic acid on the top, it doesn't drop back that much. If you wait until the oxalic acid vaporizes and you don't wait till the temperature goes back, but we right away apply the next dose, it goes down even further down. So it's not like a stable temperature curve which you can predict, but you can pretty much track with the temperature where you are, whether you finish the vaporization or not. It's, we have to get there and then measure the efficient quantity which does the job. And my experience is that with a good device, 2.5 grams is enough. Even when the supers are on full with bees and I don't get more mite drop if I treat them compared to having more oxalic acid there. This is something we should not stress our bees more than necessary. And I'm not saying that people should go back in US to 2 grams. What I'm saying is that if we measure the different devices and the efficiency they get at different temperatures, then the result may come out that one of the devices is like 50 or 60% efficient, and the other one is only 20 or 25%, depending on how long it takes to vaporize that quantity, how much it is overshooting, and so on. And nobody really looked at that. They only looked at the convenience of the tool, but not, does it do the job or not? So what we learned is that temperature has a huge effect on efficiency, how much oxalic acid is coming out to the hive. Low temperature is not necessarily better to vaporize. We have to go on to examine it more. And we definitely have to think deeper on this issue and not just until now what we did. And then I think how we should go further with this measurement. Only the oxalic acid, the acid content could be measured, not distinguishing between formic acid and oxalic acid, and that has to be further, studied so that we can distinguish between them, and then we have a full picture. Just here an example: if you have 2 grams, you get 60% efficiency. You get 1.2 gram into your hive. But if you have 30%, you only get 0.6, which is like half the quantity compared to this one. But if you are not happy with that and you apply 4 grams, but that will lower your efficiency because the temperature will even drop back more and it will last longer, you may get 1 gram, but with a better design of tool, with a better keeping the temperature, regulating it, you can get double the efficiency. And that's why I was one of the reason I kind of wanted to do this experiment, I have to tell you honestly, is that this design, this spout is so good that I can vaporize even in winter at 200 degrees, which was not possible before. And my understanding was that if I vaporize that low, then I will get much more efficiency, and I can advertise it, that it is not clogging and so on and so forth. But after I saw the result, I was not happy. Then I had to think, what is going on here, and I understood that overall it's better for the beekeeping industry to know about these results. I'm not saying that they should 100% trust it. Like really independent studies should be done by universities, by labs. I'm happy to give a device, but I don't want to be involved, because then we can say it's a published material, it was cross-checked, it was done by scientists, and it is doing this is the result, and we can trust it, and we can go ahead and implement it. I hope I can kind of get people excited to go in this direction and make maybe not maybe, but I hope definitely that there will be some people who sees it and will dig into it and will help me to find, or they will find the right companies making these measurements, and then we can have a much better understanding what is going on when we vaporize, and how we should, at what temperature and what quantity, and so on. So I think this, any question you have, but this is, I think quite exciting, and I wanted to share it and get people excited about it and get deeper into this issue.
Mm-hmm. No, that's very interesting. I'm very happy that you did that presentation on 9/11. But yeah, that's great. And I hope that you'll come back and look at comments that are left by viewers as well, maybe if you have the time. And of course, we'll put your contact information in the video description as well.
Thank you very much.
So do I have to change?
I will stop sharing.
Oh, there it goes.
Stop sharing. Very good.
Well, you did pretty good with that, considering you don't do Zoom. So yeah, that's good. All right. Well, now I want to thank you finally. I didn't realize you were going to do that presentation. That's very good. And by the way, I hope people are clear when they're looking at that and the efficiency drops are the band style heaters, and then it's being compared to that more steady curve is, of course, the InstantVap. Right?
Yes.
Okay. Any last comments, questions, anything?
Not from me. Thank you.
Not from me. Okay. Well, thanks a lot for doing that. And we're done. That's the end of the presentation. I think that's going to be very valuable, and it'll get the conversation going, I think.
I
now,
hope so.
You did your own research to try to find out if there had been any studies that already broke down those chemicals, those byproducts of the decomposition of the OA, and you couldn't find any.
No, I couldn't. And like looking at the scientific beekeeping blog, and so on, I'm sure that they would have shared it and everybody would talk about it and would reference it. And I never saw even one reference to any studies which they made. Only, even there, you only have these three temperatures. This is when it starts to boil, this is when it starts to sublimate, and this is where it starts to decompose, but nothing more.
Yeah. So you went with what you could detect, which was the acid level.
Yes.
Well, that wraps up another interview in my series of interviews with experts. Hopefully you've been inspired to look deeper into how the heating parameters used in sublimating oxalic acid may profoundly reduce the effectiveness, and that more OA just may not be getting better efficacy. This video is not affiliated with any company, and I purchased my InstantVap at full price through laurabees.com. Thank you for watching and listening. I'm Frederick Dunn, and I wish you all the best in beekeeping.